let's now move on to one of the coolest phases, and that's the analysis phase, right? So now that we've got our data, and I'm just going to write here, this process is our analysis, right? And now I've got a couple of things here that I want to sort of mention as we continue through this discussion. Now that we've gone through and we've received our images of the evidence, we've got copies of those, not making sure that obviously they're not originals. Now we've got to go through and analyze and determine what's going on. So anytime we do analysis or we're going to start doing investigations, well, there's a couple of things that we need to be mindful of. And the first thing is, well, there's a goal and obviously the objective behind the forensic analysis, right? Now, it's basically there to prove or disprove basically something that's happened or not happened. And you've got to come in and validate, is what people are saying true or it's not true. So something could have happened based on a scene, whether maybe someone has stolen maybe money out of the accounting firm's, budget or something like that, or then you've got to come in and then prove, well, did they actually steal the money or did they perform a function or do something else? And then you got to come in and analyze and then prove or basically disprove what's actually happened. So just keep that as in the back of your mind as you're sort of going through the analysis phase. Is obviously a goal there to validate or disvalidate, the actual objective on why you're there to perform your investigations. Now, as we continue through this process or through the analysis process, I should say, there's a couple of techniques that can help us. And I'm just going to say here techniques because as we cover the different techniques, the different bunch of things that can help us throughout our process. And there's one of those that's called file carving. And file carving is basically looking at, it's there's there's two pretty much two tool sets that can help us with that. One is called foremost and strings. And basically what these file carving tool sets can do is use they're basically used for finding files in unallocated spaces. So what will traditionally happen is if we've got a hard drive over here. And as the hard drive writes files to that hard drive, so you're obviously doing things, we'll go away and write something. Well, file carving, if someone goes away and tries to delete something, and they go away and delete this for sort of function on that hard drive, we've got things like the master file table. And what that basically does, that it lists out each of those files on that operating system. So where they're located on the hard drive, and it basically gives us those sector addresses so we can go in there and view them, right? So that's what allows us to happen. So when someone goes away and deletes a file from the operating system, well, it's just kind of removed from that entry. So if we've gone away and deleted this sort of file here, then it's removed from that operating system, right? And basically not from the master file table. So we're not actually erasing the actual file, and it can sort of still be recovered through unallocated spaces. So we can come in with with file carving tool sets to then basically investigate. Now, there's a couple of things as well with this where if it sits there in the OS, obviously we don't know about it, therefore we can't talk to it. So bulk carving tools is where we can come in, help us analyze that process, and obviously analyze those unallocated spaces. And then we can go away and find the files that have been deleted, or obviously making sure they haven't been written or overridden by that operating system if it's been too long. And then if someone tries to cover the tracks, well, we can come in, run the file carving tool sets, and then obviously find any that's been potentially or tried to be deleted. So file carving tool sets are a great way to sort of help us through that process of the analysis. We've also got things like our binary tool sets. And binary tool sets, it's where we basically look at the files and the applications for basically analysis, right? And typically this kind of happens when we don't know with pretty much what we're dealing with. So if the application is unknown or the file types are unknown or the application typically is unknown in the data and we don't know what it does, we're not familiar with it, well then there's a bunch of tools that we can start looking at the binary for investigation analysis to help us analyze these at a low level, right? So we've got things like hex dump, just to name a few. OllyDBG is very common. There's also Gidra. Gidra has been around for a while. And these tool sets help us analyze the application state or the actual file if we're dealing with things that we're not too sure about. Now, while we're talking on the subject of binary tools, there's a few other that I can think of as well as I sort of write this out. There's EXIF tool. So EXIF tool has been around to help us basically read images and audio files, PDF files, basically for that metadata. Now, if we need to view files and images on that hard drive or view pictures of some sort, we can actually see the dates, the locations, the activities, when was it created, or any sort of last changes to any sort of dates. So EXIF tool is a tool set that can go away, look at the metadata, and provide us with the information that we need. Now, there's also volatility. Volatility is another tool set that, if you're familiar with volatility, and we've been discussing it already, again, it can help us with the memory dumps. So volatility is another tool set that can help us, obviously because of memory being so volatile. If we lose it, then obviously the data is gone with it. So we want to preserve that and do the analysis of the memory data as well. So volatility is a tool to help us do memory analysis. And as we continue on, there's another one that I sort of want to mention, and that's something called SleuthKit. Now, SleuthKit has been around for many years, and it's one of the most common and favored um, image creation toolkits out there. So we've talked about the image creation tool sets. SleuthKit is a command line tool set to help us as well with this process. So it analyzes the disk images and obviously recovering of files. Now, if you're familiar with SleuthKit, there's a function, there's another one called autopsy within SleuthKit. So, we've got autopsy for Windows. That's the other functionality from it. It's a very popular GUI interface that helps us do that. And then there's obviously the other, I've also used Black Bag technologies, and these guys can do the transition if it's a Mac, like if it's an Apple appliance. There's different tool sets that we have to be familiar with the different operating systems. So being aware of those just for now kind of helps that process. Autopsy is one of the most common Windows ones that allows us to go through that process. The GUI, we can analyze files, look at the images and stuff like that, which is really cool. As we continue on, we've also got things like our crypto. So crypto analysis and also our steganography. Right now, if you're familiar with crypto analysis, it's basically the study of cryptographic algorithms, right? So basically, you've got a bunch of people sitting there trying to identify weaknesses and figure out how to decipher or decode them. So that's crypto analysis. Now, steganography on the flip side is usually done with hiding files within images or within files themselves. So usually what you would do with steganography is you'll take a picture or an audio file, and then you can embed, you know, hidden contents in that. So people can obviously send stuff out of the firewall, send stuff out of the organization, and really it's just an image, or if it's the document, you can sort of embed some stuff in there. So you can run, so two common applications that can help us do this. One is OpenPuff. Now, this is a really common one. I've used this in the past. It's a great tool set. You install it and then you select what function you want it to use. You put in a passcode. Now, the other receiving end, when you send it to someone else, they've got to use OpenPuff as well. If we're talking about OpenPuff specifically, and then they'll put in the same conditional entries that you've put in to basically hide the file. They'll go away, do the same thing, and then they'll get the actual, if it's something in that file that you want to conceal. So OpenPuff is one, and then we've got Snow. So Snow is a command line tool set for Windows, and it basically uses white lines to conceal information within documents. So you can go away and do that. So now that we know these two sort of concepts around steganography and crypto analysis, well, there's tools during our investigation process. If people are using steganography to hide files, um, we can then go investigate these images and the files as well. And there's a couple of tool sets that can help us with this. So I'm just going to clear this side out as we continue, just so I can write some of those tool sets out so you can be familiar with them. We've got Stego Hunt, which is very familiar and very common. So you can research Stego Hunt, and then we've got Steg Detect. And Steg Detect are pretty much the two common tool sets to help us and validate or identify if people are using, or if there's different types of attacks for hiding files within images and files and stuff like that. So if steganography is used, then we can go away and obviously run these tool sets. And then I also noticed that I didn't write the file carving tool sets as I'm just sort of looking at the screen. And then file carving tool sets, we've got Foremost. And I think the other one was Strings, which are two common file carving tool sets, the strings. So you can go away, you can look at those two and identify how to use them as well. So basically, again, as we come down to this process, we want to review our tool sets. Obviously, for carving as a certain tool set, we've got binary for dealing with unfamiliar objects. We've got to define our goals and showing that we've documented everything, and ultimately coming down to approving, pretty much proving that things have happened or disproving something during our analysis process. I hope you've enjoyed this video series. As always, see you all in the next video. Bye for now.